All right, so there's our warm-up, and it's the same thing that you guys should have observed last class. We did this too at the beginning where I gave you guys two functions. And so what we see then is that whatever that thing is over there, that log, the thing you've seen on your calculator now for a few years, maybe you didn't know what it was, but now you have a little bit of idea what it is. This is an exponential function, right? We learned about that just last chapter. So what is a log then? A log is the what of an exponential function? Inverse of an exponential function. And you could tell that because every one of these pairs match, they're just reversed. The input becomes the output, and the output becomes the input. So logarithms are the inverse of exponential functions. Okay? So, that being said, let's go ahead and title up our notes for the day. What are we on here? We're on Unit 9, Lesson 2. Objective. What is a log?
I left it.
Good job. And what's it used for? And how can we use it? That's our question. All right, guys. So we've already addressed the first part of our main objective today, which is defining what a logarithm is. It's the inverse of an exponential function. We'll give you some notes on that in a second, though, just so it's solidified in your notes. But after that, we're going to evaluate expressions. And what does that mean? Evaluate means you plug a number in, you get an answer out. So hopefully by the end of today, you guys would be able to tell me what this equals. Okay? So that's what I mean by evaluate. All right, so let's begin. Let's go ahead and take some notes on what a log is.
Isn't a log wood?
You would say that.
That would have been your joke.
No, it would have been yours. What is a log? The log is an inverse
I know, I heard it.
of an exponential function.
How do you spell log?
Hence the abbreviation.
I got that.
Logarithm.
If you spelled that wrong, could we all get 10 points of extra credit?
No. But, so that's what a log is. Now, this next one's kind of important for you guys to write down. You don't really need the squares, okay? But I'm going to draw some squares up here, all right? You don't really need the squares, so don't draw the squares, but what I fill them in with, you are going to need. So, oops. I made a boo-boo. Sorry. Okay, so this is exponential form. Exponential form looks like this. Your base goes right here, right? Your input goes here, your output goes there. So we have a to the x equals y. That's an exponential function, yeah? I do want you to write the letters. You don't need the boxes. I think the boxes would confuse you if you look back later on in your notes, but I'm just using it right now as a teaching tool, a visual aid. That's an exponential function. Remember, what is an inverse? An inverse is where the input becomes the output and the output becomes the inverse. So I want you guys to watch what happens. So now, first of all, with a log, it starts off with the word log. Okay? Then the base comes next. This number is what we call the base. And it goes right down there as a little index, a little miniature letter at the foot of the G there. Okay? Now the other two spots are where your inputs and outputs go. But I want you guys to notice this. This is my input because it's the thing you're plugging into, and then this is the output because that's the one that's all by itself. Here, they get switched, right? The y goes there and the x goes over there. So the input and output are swapped, but they're literally the same expression. This is a logarithmic statement. And I'll write the whole thing for Sam this time. Now, just for the heck of it too, if you guys want to, a lot of times people just don't know how to say this. So I'll be like, Alicia, what'd you get for answer 2? And she's going to say log, little 2, big 5, and then she's going to say the rest of it. But there's a way to say this. So I want you guys to know how to say this. How do you read this statement? Like, if I asked you to read that to me, what would you say? A to the x equals y, right? So let's write that. A to the x equals y, right? That's how you say it. Now, how do you say this one? I'll show you.
Log to the A.
You would think so, but actually it's log base A of y equals x. Log base A of y equals x.
Why does that count?
It's a new thing. You guys are learning. This is, you should, I don't know, maybe you had a really cool Algebra 1 teacher. Most Algebra 1 teachers haven't gotten to this, right? And so this is a whole new idea to you. So far, everything we've learned this year has a little aftertaste from last year, right? This should be, this stuff, well, unless you're weird. In a good way. But this one is like the first like real, oh, that's new math. I haven't seen it before. All right. So it's gonna seem foreign. It's like when you learn a new language, you're gonna be like, it's like, why do they say it that way? It's gonna sound different. So this is how you read it: log base A of y equals x. But what's important is I want you to notice the inputs and outputs have been switched. Input, output. Now the y is the input and the x is the output. They get switched around. Okay. So that's what a logarithm is. Now you guys will notice that on the warm-up today, and we'll talk about this more a little bit later, but on your warm-up today, there was no base next to the log, right? You guys see that? When there's no base, it's base 10. Okay, and we'll talk a little bit more about that later, but for now, there should be a base there typically. All right, so let me bring this to life for you guys a little bit. We're gonna be learning a new language today. You guys already speak the language of exponential functions. Let me prove that you already speak exponent. Ready? If I don't write this, but just watch. What does that equal? Okay, because you speak exponent. That makes sense to you. This statement is true. You could be like, yes, I like that. Hopefully by the end of the day, you guys will be able to, ooh, that's interesting. You guys will be able to speak log a little bit better. Because this is the same statement, just written inverted as a log. Hopefully by the end of the day you could look at that and realize, oh yeah, that makes sense too.
It does make sense.
Okay, because they're literally the same thing, it's just they're written differently. So, we're going to do an example to kind of bring that idea to life for you a little bit here. Example 1. Rewrite each expression as a log. Rewrite each expression as a log. So, number 1, here we go. Let's do this one. 5 to the second power equals 25. So you just learn, you gotta think of it this way. You're learning a new language. You're learning how to speak the language of logarithms.
I'm struggling with Spanish.
Do you want me to teach the lesson in Spanish?
No! No, we were just, me and my friend were just
Okay.
we were like, we're calling Spanish.
So guys, here's how it looks. Ready? Here's how it looks. You're always going to start off with the word log. Okay? You're always going to start off with the word log. And then you're going to put a little number right down here by the G, and that G is your base, which is 5 in this case. So we're going to put the 5 right there. So whatever the exponential function starts off with, that's what the log function starts off with too. They just put it in a different spot, down there in the corner by the G. Now the other two numbers, which go here and then over here, the other two numbers are these two numbers, but these ones are switched. They get flipped around because it's an inverse. So instead of the 2 being the input and 25 being the output, now the 25 goes there and the 2 goes there. Okay?
25 is like a.
That's a good question. So this is the base, right? This is the exponent. This is the answer, but over here it's going to have a new word to it. This is the base. This is the exponent. And the answer goes here, and we call it the argument. Why don't you guys go ahead and label that for me really quick. Call that an argument, because I will be using that language, and I want you guys to know what I'm talking about when I say argument. Argument is the number that goes after the base in a log statement there.
Why is it called an argument?
Actually, anytime you have a function where you're plugging something into it, that thing that you plugged in, that's the arguments.
You didn't get what
Are you arguing with me?
I call it argument.
I got you. Took me a minute, but I'm with you now. All right, next one. Let's do another one. Number 2, let's write another exponential statement. How about, yes. All right, how about this? 3 to the 4th power equals 81. Now, first of all, let's make sure that's true. 3 times 3 is? 9. And then another 2 3's makes another 9. 9 times 9 is?
81.
So 3 to the 4th power is 81, okay? So that's a true statement. So now we're going to write a logarithm statement that goes with this that is also true. So I'm going to write, what's the first thing I write? Log. And what's my base? 3. What's my argument? Equals. Okay, so when you learn a new language, you always think in your original language first, okay? So today we're going to be thinking an exponent to solve log. But tomorrow, I'm going to try to teach you guys to think straight from logs. But for today, we're going to have to translate. So when you're looking at a statement like this, you're asking yourself, if I give you a statement, I ask, is that true? Here's what you need to think. 3 to this power equals 81, true or false, right? Or how about this one? 5 to the 2nd power equals 25, right? So if I were to give you guys this, don't write this, but if I were to give you guys this, is that a true statement? Because 2 to the 2nd power, 2 to the 2nd power is 4. Okay? So you're going to be translating today from exponent to log in your brain, but tomorrow I'll teach you guys how you can think straight into logs, okay? All right, so let me throw some student practices at you here. Same question. I want you to rewrite it as a logarithm, okay? And that's it. So let's say I have 6 to the 3rd power. I think that's 216. I hope it is.
216.
Thank you. And then I'm going to give you guys 10 to the 3rd power, and I'm going to say that's 1,000. And I want you guys to write both of these as logs, okay? So I'll give you a second to do that. What'd you get here?
Log base 6.
216. Good job. Log base 6 of 216 equals 3. Perfect. Any questions? You said it right, too. Good job.
Wait, let's see.
All right. Did you get G to yet, Eric?
The second one?
Yeah.
Yeah, but I don't know how to say it.
Okay. Just do your best.
Log.
You can just tell me what numbers to write. It's okay.
Log. Base 10.
Uh-huh.
1,000
Good.
equals 3.
Good. And the way you would say it is log base 10 of 1,000 equals 3. And that's also correct. So there you go. Now, Micah asked, do we need to write the 10? Because he remembered I said something in the beginning. So technically, if something ever has a base 10, we don't write it.
Why?
I don't know. It's kind of like, it's called the common log, so it's really popular. So it's kind of like, it's kind of like when you stepped onto campus, you had to introduce yourself to a lot of people, right? But when I walk into a room, everybody just knows me. I don't need to wear no name badge, right? They're like, oh my gosh, it's him. And so I don't need a name badge, right? But you need a name badge. So he's so popular, he doesn't really need his name badge on. It's like,
Can you give us another 2?
How do I say it? Log base 6 of 216 equals 3.
You want to give us 2 more?
Kind of. I'm going to do the opposite now. We're going to start getting you guys into that place where you're going to be able to think logarithmically now. Just slowly. We're getting there. All right, change each expression into a log.
So it's reversing.
No, Mr. Bailey. Into a exponential function. Into an exponential function. And verify it's true.
It already comes with complicated.
Because I use big words. So basically, here it is. We're going to change a log equation into an exponential equation because we seek exponent. And once we've changed it into an exponential equation, we're going to check to make sure that it's actually true. I am going to put one false one up there, and we'll see if you guys can find it. All right, here we go. So number 1, we have log base 7 of 49 equals 2. We have log base 2 of 8 equals 4. And we have log base, I don't know, man, base 4 of 64 equals 3.
That's made it because you had to take a second. That's true.
We'll see. Patience.
My boy.
You should never have told us you were going to put a big one up there because that's all we were looking for.
Yeah. All right, here we go. So we're going to rewrite this. Ready?
Hang on.
So now, don't draw this, but exponential looks like this, right? So the base goes here, and these are the inputs and outputs, but they get switched. Okay? So in this case, what is my base? It is 7. Good. So once again, the 7 comes first. So that's what you're going to write first. Now, this is the input and this is the output, but they get swapped, right? So instead of the 49 coming first, what's going to come first? And then the... So there you go. Is that a true statement? Then that over there is a true statement. Log base 7 of 49 equals 2 is a true statement. Let's go ahead and take a look at the second one. If I rewrote this as an exponential statement, it would be base 2 to the power of equals, is that true? That's false. So that's not true. So there's our liar right there. All right, last one here. See if you can do it. We'll kind of let you guys ponder your way through here. So I'm going to use my card this time. Chris, what do I write first if I want to change this to exponential form? 4. And then what's my exponent going to be, Adrian Canizales? Uh-huh.
No,
The last one there.
Oh, I can't see. Oh, I'm sorry. I thought exponent is 4, right?
No.
Oh, wait, no, 3.
Okay. And then, well, this last one's kind of chill, but let's see. Paris, what do you think? What number goes here? What's my last number there? 64. You say things so quiet. All right, that's true, by the way. 4 to the third power is 64.
So you did throw us off.
I guess I did. Good question. Honestly, none of this is true. I'm just making things up. Let's have you guys try some. I'm just kidding. I'll answer you in a minute. I want you guys to get practicing first, though.
How many are you going to have? Let's try so I know where to write this.
Just 2. So there's that. Okay, so now you guys know what a log is. So what is a log, Leslie? It's the blank of a blank.
The inverse of exponential.
That's right, Eric. That's right. It's the inverse of an exponential function. Okay? And so we're using the definition of a log, it's an inverse of an exponential function, to rewrite it as an exponential function so that we can understand it, right? So now we're going to use the definition of a log to answer questions. Not just see if they're true, but to actually figure them out on our own now. So in other words, I'm going to give you something like this. The directions are to evaluate it, but we're going to use the definition of a log, which means that basically means I'm going to rewrite it as an exponential function to figure out the answer. So here we go. Number 1. Now, I've done a lot of these already, so it's not going to be very mind-blowing. But remember how today I said by the end of the day, you guys should be able to do something like this, right? You should be able to tell me what this equals. So that's what we're going to do right now. We're going to figure out the answer to that question. Does anybody know the answer? Very good. So you're already thinking logarithmically. All right. Now, let me show you how I'm going to teach kids how to solve it though today, because these steps will come in handy for other problems where it's not quite so simple. You ready? So the first thing you're going to do is I want you to write it again, but this time I want you to put an X over here, representing the thing that we don't know but we want to find. I want to find what that equals. I don't know what it is, so I'm going to put an X there. The next thing that we're going to do is we're going to change it to exponential form. So if I rewrote this in exponential form, what would it be? 2 to the x equals 8. We solved problems like that last chapter, didn't we? Yeah. So now what we're going to do is we're going to get the bases to match. What base do they have in common? And this is 2 to the, and then from there we have, there you go, because you just crossed the bases off, right? So we're pulling in what we learned last time to solve these log problems. So we're using the definition of a log, which means I'm changing it into an exponential function. But before you do that, you need to put an X here. After that, just do what we did last time. So let's walk through another one real quick. Log base 3 of
12.
That won't work. There's an answer for that, but we're not ready for it yet. We'll get there. Log base 3 of 27. So we're going to call this number 2. Stop. That's good, though. I'm glad you got that. Now, we'll see how well that carries over into the other problems we're going to do. But, all right, so here we go. So, Michael, what am I going to do first? I'm going to do that, but first I'm going to make it equal x, and then I'm going to change it into an exponential form. So what would that be, Michael, if I change it to exponential form? Good. And now it's a problem like last chapter. So at this point, what do I want to do, Kiara? Sorry. Wait. No, it is Kiara. Sorry. Good. And so 27 is what? 3 to the power of 3. And then what do we do now, Hannah?
Oh, you cross off the basic.
And so the answer is 3 again, right? Yeah. Okay. So now I don't mind if you guys can just do this mentally looking at it. I would encourage it. Okay? But I'm about ready to throw some other problems at you where you're going to want the process because it's not quite as straightforward. So let's do another one. This one's going to require a little bit of thought now. Good. I'm really glad to hear that. A lot of people think they're not. Oh, you have? What'd you do them for? Okay. Interesting. All right, go ahead and write that one down.
What?
Does anybody know it? What is it? Beautiful. Nice job. Huh? All right, now let's see how to do this. Ready? So step 1. Make it what? Equal x. Step 2.
4 to the power of x.
Okay, now last chapter, what did we do with that 1/16? We flipped it over, and we made the power a -1. Right? And then we matched the bases, right? So I'm going to change the 16 into what? Change that into 4 squared. And what do we do with that 2 and that -1 there? You multiply them. And so the answer is? Sure. Square roots? Yeah? Okay. Here we go.
Mr. Bailey, why did you put some homework so late last night?
It happens.
I know, I got it at like 9:30 last night.
You guys don't like that?
No.
Why?
I was in bed, sleeping. This is just.
Wait a minute. You tell me you don't like to get out of bed in the middle of the night and do math?
No. I don't even like to get up to go get water.
That's ridiculous.
And she's close to the kitchen.
I mean, everybody likes math, bro.
I was going back.
Number
5. What are you talking about?
Sorry.
That was hard.
Sorry.
Have we learned this before?
Maybe. I hope we have.
No, we haven't.
Yes, we have. I know you guys have done cube roots.
No.
Okay, man. Now you're just getting more.
I haven't done it.
All right, you guys ready?
Are you trying to kill us?
Yes.
Yeah, I knew it. What is that? Evil
We're,
math
the
teacher.
coronavirus is out, and we need to stock up on meat. So you're gonna make it equal x, right? Now what? Okay.
It's 3/2.
No,
Yes, it is.
I don't think so.
No, I don't have it.
Okay, now this is, instead of writing it as the cube root of 3, you guys remember how to change a radical into a power? No. Okay, there, you're close. Imagine there's a 1 right there. That's the top. That and the root's the bottom. You guys don't remember that?
No. Oh my god. Never done it.
Well, I hope I know we've learned this, but it's just been a while, maybe.
At least I got the fraction thing. Bless you.
All right, I'm going to throw one more at you guys. Well, actually, I'm going to let you guys try a couple now. I want you guys to figure out the following problems for me. Ready? Log base. This is student practice, yes. Log base 5 of 125. We're going to start easy and we're going to work our way up to some harder ones. Log base 5 of 125th. And then we're going to do log base 6 of, let's say, the square root of 6. Now, just so you guys know, when it's a square root, what kind of root is that? It's a 2. So I'll put the 2 there, but just be aware that when they don't put the number, that's a root of 2. But go ahead and see if you guys can figure out those answers. And I don't care if you take shortcuts and you can just jump straight to the answer. That's fine. Okay?
Hello. Oh, you started it?
Yeah.